You've seen them, I've seen them. Deepfakes are everywhere. But what happens when one of them ends up as evidence in a court case? I mean, how do you actually prove, beyond a reasonable doubt, that an image isn't real? Today, we're going to dive into a new forensic method that's all about moving past just guessing and finding that hidden digital fingerprint that can actually hold up in court.
So, to kick things off, I've got a little challenge for you. You're about to see two portraits. One of them is a totally real photograph, and the other one is a complete deepfake. All right, take a look. What's your gut tell you? Is it the one on the left, the one on the right? Man, they look pretty much identical, don't they? It is incredibly tough to tell just by looking. And that, right there, is the real problem we're talking about. It's not enough to just be right. You have to be able to prove why you're right, with hard evidence that can stand up to some serious scrutiny. A simple guess just isn't going to cut it. Now, this is where most of today's deepfake detectors really hit a wall. They work using a method that's, well, it's great for quickly flagging stuff online, but it's a huge problem in a legal setting. It's what we call the black box problem. So, what exactly is a black box AI? Well, imagine you have a machine, right? You feed an image into it, and it just spits out one of two words: real or fake. That's it. It can't tell you why it made that choice. It can't show you its work. And for a scientist or a judge or a jury, an answer without an explanation is basically just an opinion. It's not evidence. And this really gets to the heart of it. The author of the source material, Hamza Abdullah, puts it perfectly. These systems lack the three things the legal system absolutely demands: transparency, explainability, and reproducibility. You just can't cross-examine a black box. And when you put the two methods side by side, the difference is, well, it's night and day. On one hand, you have the typical AI classifier. It's a black box, you can't explain it, you can't reproduce the results reliably, and that's exactly why it often gets thrown out as evidence. But on the other hand, you have this structural method we're talking about. It is the complete opposite. It's fully explainable, totally reproducible, and it's built from the ground up to be court-admissible. It gives you a whole file of evidence, not just a one-word label. So what is this structural method, really? Well, think of it less like a magic 8-ball that just gives you an answer, and more like a digital evidence kit, like the one a crime scene investigator would use. And that's the big philosophical shift here. It's moving from just delivering a verdict to carefully gathering evidence. This system doesn't play judge and jury. Its entire job is to meticulously collect and present all the digital clues so that a human expert can interpret them. And here's just a little peek inside that toolkit. The analysis is looking at everything, from something called information entropy, which is basically the image's complexity, to frequency patterns, color distribution, even the geometry of the person's face. It's this comprehensive, multi-point inspection that leaves no digital stone unturned. Okay, so let's get back to our mystery. We've got our two images, and now we have our digital evidence kit. Let's see if we can use it to find that hidden fingerprint and finally solve this thing. So we run the analysis, and the first thing it tells us is just how scarily similar these two images really are. On the surface, a lot of the measurements come back as a near-perfect match, and that's what makes these kinds of deepfakes so incredibly deceptive. For example, take a look at the facial geometry. Their levels of symmetry and distortion are practically identical between the two. So structurally, the faces are a match. That's not our clue. Same story with color. The distribution of colors across both images is incredibly consistent. If you were only looking at these first few metrics, you'd probably think both images came from the same source. But there's one test that tells a completely different story. And here it is. This is the smoking gun. This chart shows the information entropy. Think of it as the amount of raw, chaotic complexity inside each image file. Just look at that difference. The first image, the real one, has a totally normal level of entropy. But the second image? Whoa, its entropy is completely off the charts. To put a number on it, the difference, what we call the delta, is 6.13. Now, in forensic analysis, that is a massive blinking red flag. This huge gap is a known signature of a generative AI, which basically stuffs an image full of artificial, high-frequency details to try and create this illusion of realism. This, right here, is our hidden digital fingerprint. It's not something your eyes can see, but it is an undeniable mathematical artifact left behind by the AI that created the fake. So yeah, the image on the right was the deepfake all along. So we solved our little puzzle. But the bigger story here, the reason this matters, is about establishing a whole new standard of proof for our digital world, one that puts real evidence over simple, unsupported verdicts. What this method does is create a clear, defensible chain of evidence. You gather data from all those different tests, you identify the significant differences, like that huge spike in entropy, and then you bundle it all into a transparent, auditable report that an expert witness can actually present and defend in court. And that's really the key takeaway from all of this. In a world where seeing is no longer believing, the goal can't just be about having the right answer. The goal has to be providing objective, explainable, and reproducible proof that anyone can check for themselves. Which kind of leaves us with one last big question to think about. As AI gets better and better at creating these flawless fakes, is this kind of transparent, explainable evidence the only real form of truth we have left?